Hi, I'm Kainan from Baidu Research. Today I'm going to present our work, Neural Voice Cloning, with a few samples. We know the multi-speaker speech synthesis models are conditioned on text and speaker identity. The text contains linguistic information and controls the content of the generated speech. Speaker identity, on the other hand, includes the speaker information, for example, the accent, pitch, speech rate, and so on. However, there are several limitations for the multi-speaker models. For example, they can only generate speech for observed speakers during training. Also, they require lots of speech samples per speaker. So here comes voice cloning. Voice cloning is to synthesize the voices of new speakers from a few speech samples. There are lots of applications for voice cloning. For example, the personalized speech interface, content creation, assistive technology, and so on. There are several challenges for voice cloning. For example, we need to learn the voice of a new speaker, and we have to extract the speaker characteristics from a few speech samples. Also, we prefer voice cloning with low latency and memory requirements. In this work, we present two approaches for voice cloning, speaker adaptation and speaker encoding. Speaker adaptation is to fine-tune a pre-trained multi-speaker speech synthesis model for a new speaker. The training data are a few text and audio pairs. There are also two options for fine-tuning. We can fine-tune the whole model, or we can fine-tune the speaker embedding only. Speaker encoding is to directly infer a new speaker embedding with a separately trained speaker encoder. The training data for speaker encoder are audio and speaker embedding pairs. In inference, we can feed the extracted speaker embedding from a few speech samples to a multi-speaker speech synthesis model to get the voice of a new speaker. Here are some results. From the table, we can see the speaker adaptation, especially the whole model adaptation, can give us more natural voices and more similar with original speakers. For speaker encoding, the encoding time and required parameters are significantly less, which makes it more favorable for low resource deployment. We also find we can do voice morphing via embedding manipulation. We show the simple algebraic operations to the inferred speaker embeddings are highly effective in transforming their speech characteristics, for example, the gender and accent. We can use the British male add the average the female minus the average the male to get the voice of British female. That's our work. Thanks for watching.